Hi everyone, so today I will continue with chapter 7, which is permutation and combination. In chapter 7.1, we will cover permutation, while in 7.2, we will cover combination. Okay, so without wasting time, and let's go. So before we learn about the technique of permutation and combination, so let us learn to use the technique of counting, like without the any permutation or combination. So if an event has m steps, of which the first step can be performed in n1 different ways, the second in n2 different ways, the third in n3 different ways, and etc., then the whole event can be performed in n1 times n2 times n3 times many ways until times nm different ways. So it's easy. So we just go to the question. So if there are three roads leading from town A to town B, two roads leading from town B to town C, and two roads leading from town C to town D, so calculate the number of ways of going from town A to town D. Okay, so as we know, if we want to go to town A to town B, we have three roads, which is three ways. Town B to town C, there are two roads, and town C to town D is two roads. So by using the definition just now, it say n1 times n2 times n3 times many n. So I can express the number of ways from going to town A to town D by using a tree diagram. So in tree diagram, we will learn in chapter 8 probability. So as you can see, town A to town B, there is 1, 2, 3 ways. Town B to town C, 1, 2, 1, 2, 1, 2. Here is like, if I go to A to B, so I use the first road, B to C use the first road. Then this 1, 2 is mean like I go to A to B by using the first road, B to C by using the second road. Like this A to B, go straight. So I using from A to B by using the second road, and I go to B to C can either use the first road or second road, and etc. Just like that. It's same with C to D also got two roads, so just 3 times 2 times 2, so equal to 12. Yeah, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But if in your assignment or in your PSPM, but I think this year for our batch, so don't have this chapter 7 in coming out in our PSPM. So like if it come out in like assignment or you do your tutorial question, you no need to draw this tree diagram if you master this, the uses of techniques of counting. So here's the answer. You can just write like this. Yeah. Just like see, here got 3, 2, 2. You get all the number and you just times all the number come out. It's just easy. So let's go to the definition of permutation. So a permutation is an order arrangement of object without repetition in a set of objects. For example, there are 6 permutations of letter A, B, and C. Yeah, can be ABC, ACB, BAC, BCA, CAB, CBA. Here's the easy example. The number of permutation of n different objects taken all at the time without repetition will be npn or be n factorial just like arrange it like this. If number of way to like this number of way to arrange the ABC in a row. So I can arrange like ABC like this. The first column I have I have three letters, ABC. I can choose either one letter, so 3 or 3P1. For maybe I in this column I use A, so I left B and C. So left two letters, so 2 or 2P1. And maybe I use B, so I left C, so just 1. So the arrangement is like 3 times 2 times 1. So will be 3 factorial. So how to press the factorial in the FX570EX calculator? So you just go, you can see this sign, x power of negative 1 at the upper side of the calculator. So you just shift and you get the factorial. There's one x factorial at upside, and the alpha, besides it as alpha is c. Just shift x power of negative 1, so you can calculate the factorial. So take note that 0 factorial is 1. And just now I said you take all the different object taken all and time and arrange it like you taken all ABC. So you take all, so NPN at n you delay all n, so you n factorial means the products of all the integers from 1 to n inclusive and is called n factorial. Yeah. So let me explain why 0 factorial equals to 1. Let me show an example. Like today you have exam, but you are lazy. You don't want to go, but you have no choice. You have to go because the exam is important. It's an important exam. So you don't have any choices. You just can go only, even though you don't want. So like no choice is also one choice. The only choice you have is to go to school and take your exam. Like even though you want or don't want lah. So in the the theoretical mathematics, no choice, no choice, no choice to choose equals to the only choice. So it equals to one choice. Like just now I said, the exam you don't want to go, but you have to go. So we go to the question. So using the letters of all the word product, yeah, product Product. So how many 7-letter arrangement can be made? Yeah, just easy. So you just use the 7 factorial because all the letters Product all taken to arrange in a row. So take all will be 7 factorial. So 7 factorial will be 5040. Yeah. Okay. So for this case, the number of permutation of n different objects taken are, while r is smaller or equal to n at a time is npr. So where npr equals to n factorial divided by n minus r factorial. So if there is no restriction or repetition is allowed, the number of way is n power of r. Yeah, just now you take all the thing. Just now you take all the thing, but now you just like find like simply a letter lotto. You need to choose, you need to pick 3 words from it and arrange. So you know, not take all the letters, so just 5B3. Yeah, just like that. So we go to the question. So using the letters of word product, how many five letter arrangement can be made? Okay, this is the same as just now. Just now we also use the word product, but just now we use all the letters. Just now we used all letters, but now we use five letters. So five letter, I said just now, there are seven letters. Seven letters we pilih five. We pilih five. So 7P5. Okay. So we will get 2,320. Okay, so for FX570EX calculator, if you want to calculate the permutation, can you see the, sorry, because now I'm in my college and I cannot decide where I should conduct my session. So it may be noisy. So I here apologize to you all. Okay, so can you see the multiplication button on a calculator? At the upside, it got the word like this, NPR. So in order to type this NPR, you simply put on like this, 7, you press 7, and then you shift, multiply. So shift multiply, you will get NPR, and then you press 5, and then press equal. So you will get the answer is 2,520. The number of permutation of an objects comprising of R1 identical object of type 1, R2 identical object of type 2, and etc. until Rk identical objects of type K, where R1 plus R2 plus blah 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 plus Rk equal to n will be n factorial divided by R1 factorial, R2 factorial, Rk factorial. So identical objects are objects that cannot be distinguished, like P in PPAP and so on. Like you see the P in PPAP, there are three identical P, will be 3 factorial. So if I want to arrange all of this in a row, 4 letters, so I need to put 4 factorial divided by 3 factorial. Like if they're identical, like not so important is their arrangement, because the 3P are important. So I P at here and P at here, or P at here. P at anywhere, like also the same because they're identical. So you divide by 3 factorial. For me, my understanding is like this. So we go to the question. How many ways can all the letters from word Putrajaya can be arranged? Okay, so Putrajaya has 9 letters. So it will be 9 factorial. However, you see how many A? 1, 2, 3. So there are 3 identical A. So it will be 3 factorial. So no matter how you arrange the A, because the A is identical, so they are the same, so you just divide it. So you'll get 9 factorial divided by 3 factorial. And you just 9, you 9 shift, you shift the x power of negative 1 divide by 3 factorial. So you will get 60,480. Yeah, it's just simple. So the last one in the permutation, so determine the permutation of set of object with condition. So when condition apply to the way things arranged, it then happen that permutation is said to be conditional. Okay, we just go to the question. Just like you arrange a set of object with some condition applied. So we go to question one. How many ways can all the letters from the word Putrajaya, okay, Putrajaya again, be arranged? If, yeah, just now we see we don't have any condition, right? Just ask how many ways can all the letters can be arranged. So if like this case, we consider that the nine letters are taken to arrange in a row. But now it has three condition. No, like separate one condition, and another condition. So we look at A. The first letter is P and the last letter is A. Okay, right. Just to see. Three. Okay, there are nine. Okay, nine column. So the first letter is P. So there's one P on. There's one P only. I put it here. So one. So the last letter is A. So A must adhere. So one. You have one choice only. However, so you can one A have been used. So now you have one two A. So you have two identical A left. So it will be 2 factorial, and you see how many what letters left. So include these two identical A, so you left 7 letters left. So at here you need to 7 factorial divide by 2 factorial. So how to calculate this? A will be 1 times 7 factorial divided by 2 factorial times 1. So I calculate it will be 2520. Okay. All the letters A must be next to each other. So it say that the 3A must each together. So if I take all the A's, I have 6 more letters left. So you can see if the 3A's must be next to each other, so I consider them as one column because they are stick together. They are stick together, so I consider this as one column. One, two, three, four, five, six, 7. So there are 7 places. So 7 place because the 3A, they are 3 identical. So it's not so important in the arrangement. You A also same, A also same, A also same. They are same. So if you calculate as 3 factorial, so you'll be like 3 factorial divided by 3 factorial, so equals to 1. So you no need to write. So you just use this 7 column, you arrange the like this 3A can be here or can be here or can be here or can be here. So they can be arranged. So there are 7 columns, so will be 5040. And last, they begin with a consonant and end with a vowel. Okay. So I write here. Okay. So you can see U A. There are 4 vowels. And the left 5 will be consonant. However, so you need to think that the A, let me write it. You need to think that consider the A. There are three identical A's, so there are two cases. So I write it. This is the first case. If the U is at the end, like U at the end, so you just have one U, so one. So the five consonants there are P or T or R or J or Y. So you just write this. Like this U, this U, this U, this U. Like in this I choose P, here I choose P, here I have seven more letters left with three identical A's, so I put 7 divided by 3. Here P, I choose P, so I put 1. And here, if I here I choose T with here same condition, I also 1. And here also, if I choose R, also 1. So just like this. So I can just add on this condition, here 1 all together to be 5. The 5 is include all the P, T, R, J, Y here. I don't need to add this. Oh, this is 1 plus 1 times 3 factorial divided by 3, 7 factorial divided by 3 factorial times 1 plus 1 times 7 factorial divided by 3 factorial times 1 plus 1 times blah 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 blah, because it's long, right? So you can just conclude, just combine all these consonants as they can be at this first, at the first, so you just conclude all at 5, become 5. So this is the first case, and the second case, let me use this column. The second case is A at the end. So here is the same, the P, T, R, J, Y. There are 5 possibilities, so I put 5 times 5, okay. Here the end I put A, so I have one choice only, so I put 1. Okay, so I already used 1A. So 3 minus 1, I have 2A left. So at this bottom, I have 7 letters left. However, I have 2A. So 7 factorial divided by 2 factorial. Yeah. So from this, I will get the first case, 5 times 7 factorial divided by 3 factorial times 1 plus 5 times 7 factorial divided by 2 factorial times 1. So you just add on. So here's the answer. Yeah, the case 1 is U at the end, and the case 2 is A at the end. So I just add on 4,200 and 12,600. So I will get 16,800. Okay, second question. How many 1, 2, 3, and 4 digit numbers can be formed using the digits 4, 5, 6, and 7 when each digit can be used only once? And B, how many of the numbers formed in part A are odd and greater than 600? Here's the clone puzzle question from 2009. So we can see there are 4 digits, 4, 5, 6, 7 are given. So now, how many 1 digit, 2 digit, 3 digit, 4 digit? Okay, oops. This is easy only. So if you want to form 1 digit from these 4 numbers, so just 4P1. If you want to form 2 digits, search 4P2. If you want to form 3 digits, search 4P3. If you want to form four-digit numbers, you just 4 factorial it. Or you 4p4, 4p4 or 4 factorial. For me, I like to use 4 factorial more. Yeah, sure. So I add on all the 4 plus 12 plus 24 plus 34, so I will get 64. How many of the numbers from in part A are odd and greater than 600? Okay, so there are 4 cases. Yeah, let's just go it. So we have two odd numbers, which is 4 and 6. And two odd number is 5 and 7. And the two even number is 4 and 6. So there are 4 cases. So the case 1 is the 3-digit number with when first digit is 6 and the first digit is 7. There are 2 cases in this. If it's 3, because it's just 600 what? 600 what? It just say greater than 600. It not no say how many digits. So I can consider 4 digit also, as 4-digit number is also greater than 600. So let me count the 3-digit first. So when first digit is 6, so the first the first digit should be 6. And odd number, right? So 5 and 7, maybe 5 or maybe 7, so 2p1. So I left two digits start, maybe 4 or 5 or 4 or 7. So I choose them from 2p1. So the total up will be 4. Or when the first digit is 7, so your first digit will be 7. Because 7 is the odd number and 7 had been used, right? So you just left 5 only. So 5 will be the only choice to put in the last digit. So 1. So in the middle side, you just left maybe 4 or 6, so 2p1. So you will get 2. There are 2 cases left. So this for 4-digit number. So when first digit is 4 or 6, which is the even number. So because maybe 4 or 6, right? So okay, before that, you see which, which place should be considered first, here or here? Okay, so for me, the answer is here because it has stated odd number, right? So the last digit should be considered first. Only then go to this two. So let me go to the last digit first because the first digit is 4 or 6, right? So there are no odd number have been used. So 5 and 7 can be considered into the last digit. So 2p1. 4 or 6 may be used. So 4 can be here or 6 can be here. So just sum up become 2. And there are left 2 digit left, so they can switch place, so it will be 2 factorial. And the last case, when the first digit is 5 or 7, which is the odd number. So because this 2p1, 5 or 7 or had used, which is just now I say, the last digit should be considered first. So you see the 5 or 7, here need to choose, here you have 5 or 7 here. So let's say if I pick 5, so here I have 7 only. So the 7 will be the only choice. And conversely, if I use 7 at here, so at here 5 will be the only choice to put at the first digit. And the middle 2 digits will be 4 and 6. I can arrange like 4, 6, or 6, 4. So it will be 2 factorial. There are 2 types of arrangement. So the third cases will be 8 and the fourth cases, the sum up will be 4. So I total up 4 plus 2 plus 8 plus 4. So I will get 18. Yeah. Okay, let me just go up first. Okay, so here's the end of 7.1, and now we go to 7.2, which is the combination. So permutation and combination like similar, right? Think like similar, right? Okay, so now I explain what is the difference between the permutation and combination. So a combination is a selection of n distinct objects with no consideration given to the order of the objects. So that's the difference between a permutation and combination. In a permutation, the order of the object is important, whereas in a combination, the order is not important. For example, from three pictures A, B, and C, the permutation of two objects are A, B, A, C, B, A, B, C, C, A, and C, B. There are six arrangements. Here, for this, AB not equal to BA, BC not equal to CB, CA not equal to AC, as the permutation is like there are more like more stress on the arrangement. Therefore, the total number of permutation is 6. However, in combination, the order is not important. Therefore, AB can be BA, BC can be CB, and AC can be CA. Therefore, the total number of combination is only 3. Okay, so there are just a difference between the most like the difference the most can mostly can be seen, which is the permutation will be stressed on of the arrangement, while the combination will not so important, not so stressed on the arrangement. Like see, like this pictures ABC, the AB is not equal to it just how many the two pictures are chosen, the two pictures are chosen. So how the two pictures chosen can be arranged, right? Like here, I put A at left side, B at right side, or like I put B at left side, A at right side. So they are not same because the arrangement is different. You see, A is at left here, but A is right at here. The arrangement is different. But you see the combination, I choose like same the pictures A B C. Now if I ask for the combination, the question will be like this. Choose two pictures from it. So how many ways the two pictures can be chosen? Chosen only, no arrangement, no the keyword arrangement. So I can choose A, B. So from here, there are, if I choose a B for permutation, I have two permutation, but for combination, I just have one combination. Because just A and B chosen, right? I can choose B first, then I choose A also can. Because just choose only, just pick up only and not to arrange that. So we go to the question. So determine whether each of the following is a permutation or combination. So A, 5 pictures placed in a row. And B, three storybooks picked from a rack. C, a team of 9 players chosen from a group of 20. D, the arrangement of the letters in the word October. And last, types of food in a plate taken for lunch consists of rice, vegetables, and chicken curry. Okay. So A, 5 pictures placed in a row. Because you need to arrange the 5 pictures right. So it's permutation. Three storybooks picked. You just pick only. You no need to arrange. So combination. A team of 9 players chosen. Just choose only. No need to arrange. So combination. D. The arrangement of the letters. Okay, here's the keyword. How you differentiate between the permutation and combination? You just see the most simple way to differentiate between them is the permutation have the keyword arrangement. Here I get the keyword. So here's permutation. So last, types of food taken. So for this is combination because I can choose rice first, then I choose vegetable, last choose chicken curry. Or I can choose chicken curry first, and then choose rice, and then choose vegetables. Or I choose vegetables first, or rice first, and chicken curry first also can. So there's does not have any order, so combination. So here's the answer. Okay, so determine the number of ways to form combination of R objects from n different objects. So the number of combination of n different objects taken R, while R is smaller or equal to n, R will be not bigger than n. So will be NCR, where NCR equals to n factorial divided by R factorial times n minus R factorial. Okay, so how to press the NCR in the calculator? Just now you see the multiplication button, right? With NPR upside. So now you see its left hand side. You can get there's the division button. At the upside you can see NCR. So you just shift the NCR. Shift division NCR. Like this question. We go to the question first, then I explain how to calculate this. There are 10 men, 15 women, and 12 children participating in a family day event. So how many ways can a group of 7 men, 13 women, 10 children can be formed if a particular lady and a particular child must in that group? And B, 30 participants are required. And how many ways can this group be formed if each group must consist of at least 8 men? Okay. So the condition at here is 7 men, 13 women, and 10 children. So between the 13 women, one is the must join in that group, and from the 10 children, and one is must join in the group. So for this case, here 10 men, right? Need 7, so 10 C7 times. Because one lady, right? One lady is the must, so 1C1, and left 12, right? So left 12 women, right? So 12C is, sorry, 15, 14. 15 women, so 1 is the must, so 14. So 13, one place is given to the particular lady, so left 12. Now we go to the children. One particular children, 1C1. Minus 1, 11. Here also minus 1, 9. So here will be 11C9. So it will be equal to the 600,000 and 600. B, 30 participants. So how many ways could be found for at least 8 men? You can see there's 10 men. So minimum is 8 men. So it can be 10C8, which is the minimum. While you can see 15 plus 12, so 27. So from this 27, because they not stress on the number of women and children, right? So 27 we just combine. So 30, right? So 30 minus 8, so we get 22. So from these 27 people, we pick 22. For this case, we not use plus because there are three cases. Here is only one cases. One case. Here got three cases. I can choose 8 men or 9 men. So it will be 37, choose 21%. And I can choose all the men also. Yeah, you can see just now just have one case. Is the particular lady child inside. One case. Here I can be three cases. Can be 8 men or 9 men or 10 men. So I plus all the cases. So I will get 7,000,000 480,980. Here's the answer. Okay, so how many three-letter words can be formed from the letters of the word Malaysia? Malaysia? Yeah, Malaysia have 8 letters with 3 identical A. But now we not like so there are 4 conditions with 3 identical A because 3-letter words, right? It can be it can be no A, it can be no A, or 1A or 2A or all A inside. So we just see the conditions. So if there's no A, so A are not be chosen, so you just have 5 letters MLYSI. So 5C3 and the three letters can be arranged between themselves, so 3 factorial, so equal to 60. If you have one A, the A is a must at here, so you can choose MLYSI. You pick 2 letters from it and times 3 factorial. Becomes 60. If 2A, there are 2 identical A. So there are 2 identical A is must, so in these 5 letters you can just pick one. And times the three ways that three arrangement. However, there are 2 identical A. As the arrangement between the identical objects are not so important, so you can divide by 2 because there are 2 A. So you will get 15. The last case is 3 3A inside. 3 inside just one case because you no need to arrange. How you arrange, they are the same A. So if they are all A are being used, so these 5 letters are not being used, so 5C0. And there are one arrangement to arrange this, so just one. So you plus 60 plus 60 plus 15 plus 1, so you will get 136. Yeah. So here is the end of the chapter 2. And before I end, I go to some hot question first. The hot question is the combination of the permutation and combination. So just let's go. Okay. Given a set of digits 0 to 9. So find the number of different ways to choose the 2 prime digits from the set. Number of different ways. So you can see you need to pick out which is the prime digits. So the prime digit is 2, 3, 5, 7. So number of different ways to choose. So for C2, 2 prime digits, so you'll get 6. So B, four-digit numbers are to be formed from the set and the numbers do not start with the digit 0. So find the possible number of ways of getting. The first case is even numbers between 6,000 and 7,000 if every digit can be repeated. So like just 4 digit, if at here I use 6, here I also can use 6, here I also can use 6, here I also can use 6 like that. As long as it's the even number between 6,000 to 7,000. So see, the A, the prime numbers just as I said, 6, and B here, B1. So you need to know that the range, because it said between 6,000 to 7,000, between, which means these 6,000 and the 7,000 are not included into the range. So your range will be 6,001 to 6,999 between them. They two are not included. So in this case, I arrange it 4 digit. So between the 6 to 7, right? So you can just use the number 6. So you have just one choice. Even number, so you can pick 0, 2, 4, 6, 8. So 5. Here can use 10 letters, here can use 10 digits, here can use 10 digits with repetition, right? So the total ups 1 times 10 times 10 times 5, you will get 500. So however, you see this case. If I here I put 6, here I choose 0, here I choose 0. This 0, 2, 4, 6, 8, I choose 0. This is out of the range, right? Out of the range between 6,001 and 6,900 to 99. I out of the range. So I need to minus 1 in order to remove this 6,000 outside. So will be 500 minus 1 will get 499. Here's the answer. Okay, so go to B2. Number greater than 6,000 that end with digit 5 and the digit can be only used once. End with digit 5. So here can use 5 only, so there are one possibility, one choice. Here, greater than 600, so I can use 6, 7, 8, 9. So therefore, here I use this one digit, here is one digit, so I left 8 digits. Here is 2 columns left, so from A, I pick 2 come out and arrange it, so 8P2. So my answer will be 4 times 8P2 times 1, so I will get 224. And the last, the number that contain exactly 2 odd digits and they must be next to each other with no repetition of digits allowed. Okay. This is the clone PSPN 2015. Yeah, 224. So you need to calculate out exactly 2 odd digits. So exactly 2 odd digits. So if I pick 2 odd digits, the rest will be even digits. So I need to count the number of odd digit and the even digit first. Odd digits will be 13579 and 5. There are 5 digits. Even digits will be 0, 2, 4, 6, 8. The total number will be 5. So it will be like the case. Here the 2 odd digits must be next to each other. So 5C2, if like put 1, you put 5 here. And it can be switched like 1 or 5 or 5 or 1. So 2 factorial. Here is 2 even number. So there are 3, I consider it as this as one column. So 1, 2, 3. There are 3 columns. So 3 factorial more to it. So however, if you see there's a problem, it, because the zero cannot be at here, right? If zero at here, it will be 3 digit. I want 4 digits, so I need to exclude one case, which is zero as the first digit. So the other even number, I left 2468, right? So for C1. And this will be the odd digits. So there are three the like three arrangement. So oh no, there's not three arrangement because I need no need to count because the zero is fixed at here, so no need three arrangement. Okay, so here is the answer: 1040. This is the all case. Okay, okay. Excluded the zero is at the first digit. Okay, we go to the. Is it finished? So we go to the second question, which is clone 2016. So total number of six students can sit on 10 chairs rearranged in a row. So first, find the number of different ways can all the six students can sit. You need to arrange your row, right? So this is a permutation. So the number of different ways. So there are 10 chairs, so six for six students, so 10p6. Not 6p10, 6p10 you cannot choose anything. So the first will be 10p6. I calculate it. If both seat at the ends are to be seated, so find the number of different ways this can be done. So like here, Ahmad sit at here, Mutu sit at here. So there are six. Here we sit. Like Ahmad choose first, Ahmad choose at this end, and Mutu choose at this end. So there are 8 seats left. So there are 4 students left, so 8p4. So the answer will be 6 times 8p4 times 5. Later we will see the answer. If two particular students do not sit next to each other, so find the number of different ways that all 6 students can sit. Okay. Now it says 10p6. So will be 151,200. In the second case, like Ahmad choose first at this end, Mutu choose next at this end, and the rest four students choose this eight. So will be 50,200. And the third is the two particular students do not sit. So it's hard to calculate. So for me I just use this method. I use all the ways exclude the two particular students sit together. It's also the same because they cannot sit together, right? So I use always to arrange minus the chance the two particular students sit together. So the two will be 2 factorial, and I consider this bracket, this box as one place. So there are 9 places, and for the other student to pick, which is 9p5. So I will get all case excluded the two students sit next to each other, so will be 120,960. Here's the answer. A committee consisting of two males and three females is to be formed when from five males and seven females. So find the number of different ways if a particular female must in the committee or two particular males cannot be in the committee. So if a particular female must in the committee, so will be five males remain 5C2, and particular female, the female is the mass, so 1C1. So 7 minus 1 equals 6 left. 3 places minus 1 equals 2 places left, so 6C2. Here's the answer for 1. And the two particular males cannot be in the committee, so just 7C3 times. Two particular males cannot, so 5 minus 2 equals to 3. So there are only 3 males. Need to select 2 males from 3 males, so 3C2. So here's the answer. First will be 150 and 7 will be 105. Okay. So a box contains 12 cups of similar size and shape but in different colors. There are 5 blue cups, 4 red cups, and 3 yellow cups. So a rack can only take up 6 cups. So in how many ways can an equal number of color cups that could be placed on the rack? This called PSPN 2017. It was a hot question. So equal number of color cups. So can be 2 blue to red to white, they are equal. 3 blue, 3 red, 3 blue, 3 yellow, or 3 red, 3 yellow. So because they are identical, right? So there are 6 places, right? So you need to 6 divide by the identical, all the identical thing. So 2 factorial times 2 factorial times 2 factorial. So for this case will be 90. If 3 blue, 3 red will be 20, 3 blue, 3 yellow, so 20, 3 red, 3 yellow, so 20. So 90 plus 20 plus 20 plus 20 will be 150. So B. An equal number of color cups that could be placed on the rack with cups of the same color being side by side. So just side by side, you just consider as 2B, 2R, 2Y. So there are 3 boxes, so 3 factorial. 3B, 3R. Also, there are 2 boxes. There are 2 colors, so 2 factorial. 3 blue, 3 yellow, also 2 factorial. 3 red, 3 yellow, also 2 factorial. Because 2 colors only. So 6 plus 2 plus 2 plus 2 equals to 12. And lastly, an equal number of yellow and red cups can be placed on the rack. Equal number of yellow cups, yellow and red. So it can be no blue inside. 3 red, 3 yellow. Just now I had count is 20. Can be 2 red, 2 yellow, or 1 red, 1 yellow. For this case, the blue cup must be at inside. So if 2 red, 2 yellow will be 90. 1 red, 1 yellow will be 30. So 20 plus 90 plus 30. So I will get 140. So here's the answer. So I hope that you can understand the question. So here is the end of chapter 7. I will continue with chapter 8 in my next video. So thank you and see you in the next video, and bye.